think it is visible for online students. Okay guys, okay listen, so online students, I think there's some settings, there is some problem with the settings, so I cannot make it right now. You just try to listen, the viewing part you can do later on, right? So guys, let us go ahead. PN junction diode, right? So in the previous class, right? Yes. PN junction diode. Little more sound you want, huh? If you guys keep quiet, automatically the sound will reach. Now, first settle down, everyone. Yes, are you getting the voice now clearly? Yes. When more strength is there, if 2 or 3 are talking also, the voice will break like a wall. Okay? Right, listen. Semiconductors. Semiconductors and okay. PN junction diode. You might use small letters or capital letters. PN junction diode, or simply we call it as junction diode or PN diode. So already we have discussed in the previous session that what are semiconductors and what are the different types of semiconductors, right? What are different types of semiconductors? Right. And as part of that, we have discussed the intrinsic and extrinsic semiconductors, the types of semiconductors. As semiconductors are classified into 2 types, named as intrinsic and extrinsic semiconductors, where the extrinsic semiconductors are further classified into 2 types called as N-type and P-type semiconductors. It is not like classified. Actually, the pure semiconductor or intrinsic semiconductor can be modified or converted into these N-type and P-type semiconductors by doping them, means by adding impurities to those. So these P-type and N-type semiconductors, in P-type semiconductor, as we have discussed, the majority charge carriers will be the positively charged holes.
I think your mic is not on. Mic is not on.
Not audible?
It's on. It's not in on. Off.
So you are not getting the voice? Now okay? Right. I think now okay, fine. Right. So we have discussed that P-type and N-type semiconductors can be achieved by doping an intrinsic semiconductor with trivalent and pentavalent impurities. By adding trivalent, we get P-type, and by adding pentavalent, you will get N-type. This N-type semiconductor, negatively charged electrons are majority charge carriers. In this positively charged holes are majority carriers. But you have to keep in mind that very important point. These, whether it is N-type or P-type or intrinsic, in any of these types, you have to keep in mind that any of this type of semiconductors will be electrically neutral as a whole. So, electrically neutral as a whole. So, you have to say net charge in any of these will be equal to 0. This is not positively charged semiconductor, P-type. It is electrically neutral, but the majority charge carriers in this majority charge carriers will be positively charged holes. That's it. But equal number of positive charge and negatively charged carriers will be there because of doping. We will be using the doping material also, right? So this you need to remember that point. Now our main point of interest is, if you bring one such a small slab of P-type semiconductor and N-type semiconductor, if you bring one P-type semiconducting material, a slab of, and N-type semiconducting slab, and if you join them, not just by bringing and simply keeping side by side, it will not form a PN junction diode, right? Yes, N-type. By using some special methods, by using some special techniques, if you join them, then this in this the majority charge carriers are holes. More number of holes will be there, and less number of electrons will also be there. And in this, more number of electrons will be there, and less number of holes also will be there. When you keep this aside, and if you join these two pieces by using some special techniques like a diffusion method, some special techniques, because of charge carrier concentration, here holes are heavy, large in number, here electrons are large in number, but here electrons will be there. So just like if you take one incense sticks, if you light it, or if you take one spray, and if you just press the spray button, right, the spray will diffuse from the place where it is having a larger concentration to lower concentration. Say something like if you lit some fire somewhere here nearby, so that the fog will move from one place to another place, means where it is having a larger concentration to the places which are having a smaller concentration. Like that, it will diffuses. The phenomena we call it as diffusion. Same way, electrons in this region will try to diffuse to the region where the number of these carriers are lesser in number. Is this point clear? In this process, these electrons, negatively charged electrons, will try to diffuse from this side to this side, from N side to P side. And in this process, they will recombine with this hole. When it comes here, this will recombine. So the positively charged and negative charge will recombine. It will become actually neutral. Is it clear? So likewise, but the moment it comes here, a hole will be generated, and this electron will try to come on this occupy the empty space. Then likewise, this majority carriers from here, negatively charged carriers, will try to move from here to here by forming what we call this. When we form here, this electron, even when electron come and occupy this empty space, it will create a region where no charge is there. We call that kind of region is depletion region. What region? Depletion region. So with the positive and negative charges, like this hole and electrons will recombine in this region and forms a region called depletion region. But still, the charge carriers will try to diffuse from one side to another side. Till certain extent, when they are continuously coming and recombining, a region will be formed called as depletion region. This process, even some minority carriers also will be here, right? So because of this, it will create some different opposite kind of charges. In the positive charge, this is holes are positive charge carriers, right? Positive charge carriers. So minority carriers are electrons. So in this side, negative charge layer will be formed and in this side positive charge layer will be formed. When the electrons comes here, the hole will be created. Hole will be created, and few will recombine, and few the the probability may not completely, but in that process some negative charges due to the minority or this diffused ones will be created here. And as a result of this, it will create some field because of the charge in this region, so that in turn will create a potential called barrier potential. If a field, electric field develops here, and if the thickness is something like x or d, anything you can call it as potential barrier thickness or d or x, and potential difference across this region can be expressed as E is equal to Vd, or V is equal to E by d amount of potential will develops. If this potential continuously increases after reaching a particular value, the electrons from here cannot be able to diffuse. Then this formation will stop. Now, if you connect this, now actually a region called depletion region has formed. Now if you connect this, this slab, we can call it as this region, we call it as this entire setup is called as PN junction. A junction is formed due to this P slab and N type slab. So this entire species is called PN junction species, that has given a name called diode. Diode means actually that name is taken because of two terminals, one P type terminal and an N type terminal will be given, so it is called as diode. In the same way, another device we come across in the next sessions, we will discuss about that. And transistors. Transistor will have three, we call it as regions, and three regions, and hence three junctions also it will come up, three connections it will possess a transistor. So you can call it as triode. Triode also you can call it as. Just like here, diode, we are having two connections we can give to this, which is having one particular junction. Two connections can be given to this material which is having one junction, so you can call it as a diode. PN junction diode. This junction is called PN junction. So a diode, two polarity material having one junction called P type and N type junction, so we call it as PN junction diode. That is briefly why it is named like this. We no need to go in detail about that. Now, what happens is, if this PN junction diode, if you connect this, if it is having P type material and N type material, if you connect this to a battery, external power supply or source, we connect this to a battery, so that positive terminal of the battery is connected to P region and negative terminal of the battery is connected to N region. This kind of connection will be called as forward bias. What bias? Forward bias of the diode. In this forward bias, what happens is, already this depletion region has happened. Now here the positively charged holes are there. These are positively charged holes, and some minority charge carriers also will be there, called electrons here. Here negatively charged particles like electrons are there, majority charge carriers, and in addition to this, some holes also are there, positively charged, minority charge carriers also there. Now if you connect this positive terminal to this, the positive terminal will repel these positive charges. Holes are positive charges, right? Repel these positive charges. So now the holes will try to cross this region, and similarly negatively charged, negative terminal of the battery will, when it is connected to this negative N region of the diode, this negative charge will repel these negative charges. As a result, these will try to come this side, this will try to come this side. In this way, the region thickness will decreases, or depletion region thickness will decreases slowly, and finally, after reaching a steady state, the current due to this in the circuit will increases gradually. The current will increases gradually in forward bias. So when you connect P and N type species or P and N type materials to positive and negative terminals of the battery. Whereas if you connect in other way, the reverse way, we call that connection as the reverse bias connection. So what is that reverse bias means? Instead of connecting P-type to PD positive terminal and N-type to negative terminal of the battery, if we have P-type semiconductor and N-type semiconductor with a small depletion region or potential barrier also can call it as. If we connect this to the battery so that if P is connected to negative terminal of the battery and N is connected to positive terminal of the battery, this is positive negative. These are positively charged carriers are majority charge carriers, and negative charge carriers are majority charge carriers. This negative terminal will attract the positively charged majority carriers towards this. So this will try to travel in this external circuit. Similarly, this will attract the positive terminal will attract the negative carriers here. So this instead of crossing here, now they are coming, even the electrons here or this nearby, they will try to move away and away from this junction. In this way, the thickness of this region, depletion region or potential barrier will increases. As a result, even minority charge carriers, it is if there are no carriers are flowing and the circuit is not completing. So when the thickness is very small, the potential barrier is such that the minority charge carriers can cross this region and may consume some current. But when the thickness of this region increases, even minority charge carriers also cannot cross this region and they cannot constitute any current. So overall, in this region, in this bias, we call it as reverse bias. Reverse bias. Current will decreases gradually, and at the in steady state, after reaching some time after some time called steady state, in steady state, no current will be passed through the diode in the external circuit. So if you replace or represent this with the help of some symbol, diode symbols, the symbol of the PN junction diode is this. PN junction diode is this. If you connect this diode to the battery the same way, this will be called as P region, this is called as N region of the diode. In the symbol, this is that symbol for PN junction diode. PN junction diode. This kind of connection is called forward bias connection. So now it will conduct, the diode will conduct the electricity. So in this connection, as they are crossing easily, the thickness will decrease and the free electrons can flow easily. And thus it constitutes the current. So that can be re-represented in this form with the help of the symbol. So this is the circuit diagram for forward bias of PN junction diode. Here, usually the diodes will have some internal resistance also. Sometimes when doing the numericals, it will be mentioned that diode potential barrier, the diode potential or barrier potential of the diode will be given, and the internal resistance of this will be given. Sometimes the external resistor also will be connected. In this external resistor also will be connected. And if you given the battery with the potential V is equal to some 5 volts or 3 volts, something like that, if it is connected to a diode having some potential barrier of barrier potential of 0.7 volt or 1.1 volt, these volts depends on the material with which the diode is made of. If the material, the diode is made of germanium or silicon, the potentials, barrier potentials will changes. So if at all this is given, and if it is not having any internal resistance, external resistor is 10 ohm, for example, I am telling. And if you are asked to find what is the current passing through the diode, what is the current passing through the diode, then just by using Ohm's law, V is equal to IR, V is equal to IR, so you can say I is equal to V by R take. But here, this is positive terminal, negative terminal, this is positive negative terminal. The potential barrier is 7 volts, means what does that potential barrier means? You should understand that if you increase, if you apply this potential to a diode, if you apply the potential to a diode, or if it is a variable power supply and you are increasing the potential from 0 volts to some 5 volts. If you increase the potential from 0 to 0.1 volts to 0.2 volts, 0.3 volts, like that, what happens is the electrons here, you can just compare these two. It is forward bias. If you give this some potential, this positive potential will repel this. So these positive charges will try to just cross this, but because of this potential barrier, they were not having enough energy, so they cannot cross. Going on, if you are increasing this potential, that means you are giving more and more energy. Then at a particular instant of time, when they get enough energy, then they will start crossing, and hence the current will start flowing in the circuit. That particular minimum value of potential required to cross this is nothing but the potential of this barrier, or we call it as barrier potential. Barrier potential. Usually barrier potential for any diode will be fixed. So if it is germanium or silicon metal, so for example, if it is germanium and barrier potential is 0.7 volts, then if the potential, if you are giving 0.1 volt, but barrier potential is 0.7 volts, it cannot cross. If you give 0.2 volts, it cannot cross. 0.5, it cannot. 0.7, now it is got enough energy to cross. So because of this energy is opposing this. If you give more than 0.7, then the current starts. This you can draw with the help of a graph. We call it as IV characteristic graph or VA characteristic graph of a diode. For forward bias, VA characteristic graph, VI characteristic graph, characteristics can be represented with the help of a graph by taking potential and current. If you increase the potential, if potential is 0, anyway no current will be there, and potential is 0.1, 0.2, 0.3, 0.4, up to 0.7, no current cannot be observed. After which, if you say this is 0.2, 0.4, 0.6, something like that, at 0.7, the current starts to increase, and it increases gradually. You can't see this? Okay. So this reverse bias we'll see later. The diagrammatical, VA characteristics of reverse bias. First, forward bias. In forward bias, if you increase the potential and if you compare this and that, if you are increasing this, here the positive charge barriers cannot cross until they obtain the potential which is greater than what you call barrier potential. After that, till that, there will be no current. Till that, there will be no current. That you can understand with the help of this graph. When you increase the potential beyond 0.7 volts, then it increases and it gives the what you call current. It increases then gradually. Whereas in reverse bias, normally if you increase the negative potential, if you compare this reverse bias one, so we will see the reverse bias afterwards. First, try to have a note of these points. PN junction diode. The circuit symbol. What is the circuit symbol for diode? This is the circuit symbol for PN junction diode. This will be positive terminal, positive region of the diode. This is called the negative region of the diode. So we call it as PN junction diode circuit symbol it is. Usually in circuits, this kind of symbol only will get. Okay? So for PN junction diode, what is forward bias? Write down what is forward bias, everyone. What is forward bias means? Right? When the P region of a diode, is connected to positive terminal of the battery. When P region of a diode is connected to positive terminal of the battery, and N region of the diode is connected to, negative terminal of the battery. Then it is said to be in forward bias condition. So you can define in different ways. Okay. So what is forward bias? the sentence formation you can change the other way also, no problem. Then it is said to be in forward bias condition. Which is said to be in forward bias condition? The diode. Okay? Next. So it is shown in figure. Draw this one and that both. P region, N region. P region is connected to positive terminal, N region is connected to negative terminal. With circuit symbol, the same thing you can express like this. Without the numerical values, general representation you take. General representation you take. This is called P region, N region. So this is called forward bias connection. Forward bias connection. Okay? Next, another write down. In forward bias condition, the diode starts conducting. When the applied potential is in forward bias condition, the diode starts conducting when the applied potential is greater than barrier potential. Barrier potential is greater than barrier potential. Right? It is shown in VA characteristic graph. Now draw this VA characteristic graph. Here you can connect here. Resistor R as well. Yes. Have you copied this? From this, you can understand a few more points that if you have a VA characteristic graph, if you take the slope of this graph, this is delta I, this is delta V. Delta I by delta V. What will you get? Delta I by delta V. V by I gives resistance, but reciprocal of resistance will get. So 1 by resistance, it is called conductance. The other way you can say that reciprocal of slope, 1 by slope is equal to resistance. 1 by slope is equal to resistance. That side, is okay? So resistance is equal to 1 by slope. Is equal to 1 by slope is what? Delta I by delta R. Delta I by delta R. Delta I by delta R. Delta V.
Delta I by delta V.
Delta V by delta I by delta V. So not delta R, delta I by delta V. I by V or delta I by delta V. From Ohm's law. We will get that from Ohm's law. Right here, sometimes you may get the questions, simple questions based on forward bias and reverse bias conditions. Forward bias copied. Next, write down briefly about reverse bias. I'm erasing this. After this, just we will try to give you some related questions. Reverse bias. Reverse bias. When a diode is said to be in reverse biased. When a diode is said to be in reverse bias? When the P region of the diode is connected to negative terminal of the battery and P region is connected to positive terminal of the battery, then the diode is said to be in reverse bias. The other way, instead of using the terms positive terminal and negative terminal, you will confuse if you use the positive and negative terminal, but the actual terminology which you have to use is when P region is connected to positive terminal, this is connected to negative terminal, forward bias. So instead of that, what you have to say, even forward bias also, when P region is connected to high potential, instead of negative terminal, high potential, and N region is connected to low potential, then it is said to be in forward bias. In reverse bias means this will be in the reverse one. When P region is connected to low potential and this is connected to high potential, we express that with the negative and positive symbols. But the textbooks, if you observe, the definitions will be like this only. What is that? P region is connected to negative terminal and N region is connected to positive terminal of the battery, then it is said to be in reverse bias. But, yes, but what you have to say actually, when P region is connected to low potential and N region is connected to high potential, then it is said to be in reverse bias. What does that mean? I will give you some examples here. So first, write down reverse bias. Reverse bias. When P region of a diode is connected to, right, when P region of a diode is connected to low potential, within bracket negative terminal, for understanding purpose you can write, connected to low potential, and N region of the diode, I am repeating, when P region of a diode is connected to low potential and N region is connected to high potential, then it is said to be in reverse bias. Now I will give you some examples. See, there is a diode, it is connected to, so this also you have to put, actually, this and this both should be there to represent a diode symbol. Actually, only this symbol you are using, this is symbol for gate, one of the gate. What is that gate? Not gate. So be careful about while drawing this. Actually, you will use this. Okay? But, so this is the symbol for gate, diode, and this is for symbol for not gate. So don't confuse about this, what do you call this, symbol representations. Here, if you are using a resistor or without using a resistor, no problem. This is one junction, this is another region, this is A, this is B, provided it is a diode, it is a resistor, so that if it's, this potential is some plus 5 volts and this is plus 10 volts, and this is one. Second example is, if the diode is connected to resistor, so that it is connected to 0 volts, and this is something like 10 volts, this is connected to 5 volts, means plus only, no sign is there means. And another example is, if this is a diode, following, connected to resistor, this is a diode, and this is connected to minus 2 volts, this is connected to minus 5 volts. And the other way, minus 5 and minus 2, if it is there, then which one is, let us say this is that also, fourth one, if there is the diode and it is connected to resistor, and hence it is at minus 5 volts, and this is at minus 2 volts. Which is, out of this 4, which is in forward bias condition and which is in reverse bias condition is the question. First one. Which kind of bias it is? So for this diode, this is P region, this is N region. P region is connected to +5 and N region is connected to +10. If you observe these two potentials, higher potential is this, lower potential is this. So P region is connected to lower potential. Even though there is no negative terminal, positive terminal, even though both are positive potentials, lower and higher terminology you have to follow. This is lower than that. So P region is connected to lower and N region is connected to higher potential. That kind of combination is called reverse bias. So this is reverse. Write down this. Reverse bias. Reverse bias. Got it? Whereas what about this? P region, this is P region, this is N region, is connected to 10 volts plus 10, no sign means plus, and then is connected to 5 volts means plus 5. So this is higher than that. So P region is connected to higher potential, N region is connected to lower potential. So this is in forward bias. This is in forward, you can say forward bias. And what about this? -2, -5. -2 is smaller than -5 or greater than -5? Negative values, if you say. So scale 0, +1, 2, 3, positive increasing values, -1, -2, -3. If you take actually, when you are going towards lesser negative values, so this -3 number is more. If you compare these two, -3 and -1, -3 number is more, but the value is more negative, is lesser value. Comparing with reference, you cannot get this is reference. So these are higher, these are increasing order, decreasing order. We are coming in decreasing order. So here -2 is this, -5 is somewhere here, is still lesser value. So -2 is higher than -5. So it is relatively high potential. Are you following this point? It is relatively high potential and this is relatively at low potential. So P region is connected to high potential and N region is connected to low potential. So this connection is said to be in forward bias. Is it clear, everyone? Yes. And what about this? Obviously the reverse way. So reverse bias. Is it clear, everyone? So similar to this, one more way of representations you will come across in exams. That is, if this is a diode, it is connected to some resistor, and here we have this region you have connected to ground. Here you have connected to some potential, let us say 5 volts, plus 5 volts. So this is diode. Yes, diode, this is resistor. Then, what is this? It is in positive, reverse bias or forward bias? How many say reverse bias? Raise your hands. How many say forward bias? Okay, equal in number. How can you justify that? Let us see. You have to remember that this is grounded. The potential of grounding always you have to consider as 0 volts. 0 volts. If this is 0 and this is 5, this is P region and this is N region. Relatively, 0 is less than +5 or more than +5? Lesser. 0 is lesser. 0, 1, 2, 3, 4, 5. In positive scale, no confusion. Negative scale means you have to be a little more careful. But positive scale, no confusion. This is 0, this is +5. So this is lower potential and this one. So lower potential is connected to P region and N region is connected to higher potential. So it is in reverse bias. Which bias? Reverse bias. Got it? Whereas if it is connected to ground and it is connected to negative potential, negative value, something -2, -3, something like that, then it is relatively at a higher potential than this. Got it? Yes, otherwise, the another question, similar one I will give you, because you should be able to compare this. This method of questions is one of the very important method in based on this diodes. So if you have a PN junction diode and it is connected to something like this, resistor and it is connected to a ground, and here it is connected to what is this, minus 2 volts, and it is some resistance R. Then what about this? It is 0 volts. Usually if it is directly connected to this, no confusion, otherwise there will be some potential drop also you have to consider. Even then, the potential, this kind of representations usually will not come across. If it come across, it will give you some confusion, because along this also some potential may drop. So what will be the potential here? You have to decide then. Based on the numerical value only, then you can decide about that. So that's why usually we connect this directly to the ground. Now here, if it is connected to a resistor, then it is connected to negative potential of minus 2 volts. Then you can decide, of course, it is at a 0 and minus 2. It is relatively higher than this. So P region is connected to higher potential, and region is connected to lower potential. So it is in forward bias. It is in forward bias. Is it clear, everyone? So this is one method of questions we will come across based on diodes. The another kinds of questions are by giving the barrier potential, resistance value, and battery potential, and by asking what is the current flowing in the circuit. Those are another kinds of questions we will come across. Okay, so this is briefly about what you call PN junction diode and forward bias and reverse bias and IV characteristics. For IV characteristics of forward bias, I have saw, right? Similarly, if you see the IV characteristics of a reverse bias, so if you take the V and this is V, I and I. So in reverse bias, as barrier is increasing, if you imagine that increasing, current will not flow even if you are increasing negative potential. If you are increasing negative potential, current will not increases. But what happens is, after a particular stage, the minority, there will be a small amount of minority carrier current will be there. Small amount of minority carrier current will be there. Even then you are increasing the barrier potential. Beyond some value of this, even that also cannot be flown, but a breakdown will take place due to that. And the current will be increases what you call sharply. But without that, if you say, this will be the graph for VA characteristic graph for reverse biased current, reverse biased diode. Without this, so there will be no current at all. Only the current will, due to minority charge carriers, will be obtained. Is it clear? But overall, one more point here you have to keep in mind is that total current, which is called diffused current in a diode, is equal to electron current plus hole current. It will give you the total current. Electron current plus hole current will give you the total current in a diode. This in terms, sometimes we express it in terms of drift velocity also. Drift velocity. So, you know, in current electricity, if you remember, I is equal to NEAVD, because in terms of free electrons, as I is equal to NEAVD. If N is number of carriers and E is charge of each carrier, A is area of the conductor. Area of the conductor. If you consider a conductor, here we are considering dealing with a semiconductor. So area of the semiconductor material, and VD is drift velocity obtained by the carriers when you apply a potential. This drift velocity can also be expressed as drift velocity is equal to mobility, as mobility is equal to ratio between drift velocity and electric field. Yes, drift velocity and electric field, or you can say drift velocity equal to mu into E, mu into E. This mu into E further can also be expressed in terms of potential also. Potential E is equal to V by D. So in different ways you can replace this, and depending on the given data while doing numericals, you have to replace this here and you have to write it in terms of mobility or electric field, whatever it is. So this is also equal to NE, A, mu into E. So if you replace this I, E and IH, when you write for IE, number of electrons you have to consider, and you are writing for IH, hole current, number of holes you have to consider. And mobility of here, I have to consider this is mobility of holes and mobility of electrons, that will be different. So that also you have to consider accordingly. Is it clear, everyone? So you have to write the expressions of this, and you have to, if you substitute it here, you will get the total current in a diode due to both electrons and holes. So total current in a diode is equal to sum of the diffusion currents of electrons and holes. It is given by this. So similarly here you can write E is equal to Ne, E, A, mu E. Substitute these two and you will get a different expression for capital R, the total current. What is? If at all, if you come across any question based on that, you should be able to answer those by using the given data. By using the given data. I hope that is visible. Can I erase this part? Have you copied this? Right. These questions, especially, you should be a little bit clear about the forward and reverse biased conditions. Okay. This one you can say, you can write finally. In case of a diode, if you have in general current in a diode can be expressed as I is equal to IE plus IH, diffusion current is equal to NE E A mu EE plus NH E A mu H E will write. So here the common terms, if you take out, what are common terms? EAE. If you take it out, then you can write it as EAE into, what is this? NE mu E plus NH mu H. Here again you can write E in terms of potential by E equal to V by D. Or the D if you take it as L and A is L into L. L square if you take, if the element is in square form or rectangular form, L into B if you take, L will get cancelled, accordingly you will get a different form. So that you have to understand by looking into the question and the data in the question. Right? So let me again revise the points systematically, point by point. PN junction diode. What is PN junction diode? The diode formed by connecting one P-type semiconductor and N-type semiconductor by using some different method. We call it as PN junction diode. In this PN junction diode, a depletion region or a potential barrier will be formed due to the diffusion of charge carriers. Now when it is connected to a battery, so that P region is connected to high potential, N region is connected to low potential, it is said to be in forward biased. In forward biased condition, the diode will conduct electricity. Whereas if you change the connections, that is P region is connected to low potential and N region is connected to high potential, then it is said to be in reverse bias. In reverse bias, the diode will not conduct electricity. Is it clear? Yes? So sometimes simply the questions will be asked like this. If you have something like this, a diode in reverse bias, what is the current rate? There is a diode. There is a diode connected to 10 ohm resistor, and this is P region and N region, and it is minus 10 volts, and this is minus 2 volts. Minus 2 volts. What is the current through the diode is the question. What will be the current through the diode? What kind of bias it is in?
Reverse bias.
Reverse bias. In reverse bias, the PN junction diode will conduct? No. Is it clear? No. Then no need to worry about it. So it is not conducting means current. So you have to write in reverse bias, PN junction diode does not conduct electricity, and hence current rate is 0. Current rate is 0. Is it clear, everyone? Whereas if forward bias condition is given, then appropriate values will be given. Yes, you have to apply Kirchhoff's laws. What is that? Net potential should be equal to 0. By using that, you have to find the current. So these kind of questions here you may not get. So these are some basic kind of questions you may come across. You need to have an idea about this. Is it clear, everyone? Any confusion in this or the previous questions? So this is briefly about PN junction diode and how the questions will come across based on this. The next one, the application of diode as yes, Tana, yeah. So actually there is some problem is there, so we are not able to give you the video now. Yeah, some of you are mentioning the video is not clear. Yes, yes. So the software problem it is. So for those, I will try to give the same concepts in a proper way. We can go through that. Okay? Don't worry. Right. So the next one is what is that application of PN junction diode as a rectifier. So what is the time now?
7:30.
7:30. So can you take some anyway the time 7:45, right? 7:30 only. Okay, then I will wind up. The next concept, a small one, that is rectifiers. We will try to cover that in one more section, maybe tomorrow evening, same time. We will try to cover that. So take care.